Hello everyone. In this short video, we're going to talk about something called switching algebra. This is one of the fundamental concepts we have to learn while you're trying to design and optimize any digital logic circuit. So let's get started. Let's talk about addition first of all. We're going to talk about addition in here. Now let's look in here. We have a simple OR gate that performs addition with two inputs A and B, and the function performs f equals a plus b, right? So what we have here are two inputs, A here and B here. We are performing a plus b, 0 plus 0, that becomes 0, 0 plus 1 becomes 1, 1 plus 0 becomes 1, 1 plus 1 equals 2. And one thing I want you to observe here is whenever there is an input 1, like for example, whenever you try to add something with 1, okay, no matter what you add, doesn't matter if you're trying to add a 0 plus 1, it becomes a 1, or if you add a 1 plus 1, it becomes a 1. So what I'm trying to say is, it doesn't matter what you use here. When you add something to 1, this always becomes 1. This is one of the fundamental properties in switching algebra here. Anything added with 1 becomes 1. Now, let's look into multiplication. Similarly, if you see, we have multiplication function f equals ab here. F equals a times b is what we have the function here. So we have inputs A, input B, output F. So we multiply 0 times 0, we get 0. Multiply 0 times 1, we get 0. Multiply 1 times 0, we get 0. And multiply 1 times 1, we get a 1. So what we are saying here is any time you multiply any number by a 0, if you see here, I have a 0 multiplied by something, I get a 0. I have a 0 multiplied by 1, I get a 0. So the point we are trying to make here is, if you multiply something by 0, you always get a 0. Doesn't matter if you multiply by 1 or a 0, 0 multiplied by something is always 0 multiplied by x or whatever. This is always gonna be 0. So this can also be written as 0 multiplied by something is always equal to 0 here. Okay, this is one of the properties in switching algebra. Let's look a little more. Okay, now we said 0 multiplied by something is 0, but what about 1? So let's look here. What is x multiplied by 1 equal to? Let's see. X could be either 0 or 1, so let's verify. 0 times 1 becomes 0, 1 times 1 becomes 1. So in other words, when we multiply something by 1, that becomes the same as that something. So in other words, x times 1 becomes x. That is one property here. X times 1 or 1 times x equals 1. Okay. Now, one last property we need to know is what is x times x bar? X times x bar is what? So x could be a 0. If x is 0, x bar would be a 1. So 0 times 1 becomes 0. And if x is 1, x bar would be a 0. So 1 times 0 is 0. So no matter what you multiply by x, we get x times x bar is always 0. So x times x bar is always 0. So this is one property we have to remember here. So let me highlight the properties we have to remember. X times x bar is 0, right? 1 times x is 1, 0 times x is 0. Here we have x plus 1 equals 1. And similarly, let's look into the other properties here. What is x we looked into x plus 1 is 1. What is x plus 0? So x could be a 0 or x could be a 1. Add these both to 0. Let's see, 0 plus 0 becomes 0, 1 plus 0 becomes 0. So what we're saying is, when we add anything to 0, sorry, my mistake, 1 plus 0 becomes a 1. So when we add any number to a 0, that will be the same number. So the answer is x plus 0 becomes x. This is one property here. Now the last one, what is x plus x bar equal? If x is 0, x bar would be a 1. So 0 plus 1 is 1. If x is 1, x bar is 0. So 1 plus 0 is 1. So no matter when you add x as 0 or 1, x plus x bar will always be x plus x bar equals 1 all the time. So one of the other properties we have to remember, x plus x bar equals 1, x plus 0 is 0 here. Now let's look into a couple more functions here. Now we have to learn something called literals. A literal is like if you're given a function ABC or any function for that matter of fact, ABC, I'm giving this function of ABC, just count the number of input terms in its true or complement form. So here we have A1, B2, C is 3. So number of literals in this function is going to be just 3. It is the number of input variables or its complement in a given function. Here we have 1, 2, 3, 4, 5, 6. So we have 6 literals here. The second one, we have A is 1, B is 2, A bar is 3, B is 4, C is 5. So 5. The next one is A bar, B are 3. The next function is we have 3 here, we have 2 here, total of 5. That is a literal here. Okay. Now what is a product term here? A product term is nothing but one or more literal. A literal could be A, it could be A bar, it could be B, it could be B bar, it could be C, C bar, or anything for that matter. Any product term, anytime you see a product of one or more than one, it could be AB, it could be A bar B C, it could be A bar B bar C bar, it could be anything. Anytime you see a product of more than one literal, it is called a product term. Now the last one of the most important here is something called the minterms here. Minterms, that is one of the most important here in a logic circuit. So a minterm is nothing but a product term with all inputs in a logic circuit. So let's say we have a logic circuit that looks something like this one. Okay, I have A, B, and I have C. Okay, so we need to have a circuit. When we have a circuit like this, any product term, this is a product term because it could be written also as A times 1, right? So this is a product term, but this is a product. But min, is it min? The answer is no, because it is a product term, but it has to have all inputs. For example, when you have inputs AB, all the inputs AB, that is a minterm. A bar B bar, that is a minterm. A B bar, that is a minterm. So in other words, a product term is a minterm is a product term with all the inputs in its true or complement form. And next comes the question of how many minterms can a logic circuit have? The number of minterms in a circuit with m inputs is equals 2 to the m. So any circuit with m inputs can have 2 to the power of m minterms.